somebody told me this is a life science presentation, so I should have disclaimers, so here we go. Here's my relationships with commercial interests. We're not very good at getting grants, so we don't have any grants, so we're safe on that one. We're kind of a equal opportunity consulting firm. We'll take money from anyone, including some of you pharmas. We do occasionally get very minor speaking fees and honoraria, but luckily so far nobody's been able to bribe us enough to change our opinions. And here's the real disclaimer. You don't take this as professional judgment. Your mileage may vary. These are opinions of the speaker and may be disavowed by his employer at any time. And finally, no animals were harmed. Okay, we're ready to go. Does everyone know what this is?
You want more than that table,
Yeah, this is a silo factory. This is where silos come from. We have a lot of our clients keep asking us, where are these silos? We have silos everywhere. Where did they come from? Here's where they come from. Business has a problem, and problems almost always some line is going in some bad direction, or wow, what are we going to do? And they almost always convene a committee around that table, and most of the time it's a reorg, but if it isn't a reorg, it's an information systems problem. So that's a little above their leagues. They put together a different team who says, oh yeah, we got an information systems problem here now. What are we going to do? And they think they're making a decision at this exact junction. They used to think it was a two-way decision. Now it's a three-way decision. They used to think we're either going to build or buy a solution to this problem. But now they get build, buy, or rent. We have software as a service now. So now we have three choices. But actually it's a total non-choice, because no matter which one of those three you pick, what you get is an arbitrarily different brand new data model. No matter if you build a system, if you buy it, or if you go out and rent it, somebody has created a data model that's going to solve that problem. It's arbitrarily different than any other data model you have. And a silo is born. That's how it works. That's where they come from. And we call, and this also sort of going on with where Dale was going yesterday, there's a mindset, remember mindset, skill set, tools. The mindset here we call the application-centric approach, which says I have a business problem. I'm going to go get an application to solve it. And when it's solved, I've created a data problem, but I solved my application problem. We also less kindly call this the application-centric quagmire, because what we notice is once people get in it, the more they struggle, the deeper they go. And after a while, if I just do work harder, I'll get out of this. Interesting timing also relative to this mindset idea. This book just came out last week. It's pretty interesting. I'd recommend it. Roger Martin's claim is that in general, we have these mental models, these mindsets, and we don't even know we have them. We just walk around with them in our heads. And when we want to go solve a problem, whether it's a personal problem or a business problem, we just apply our mental model to the problem. And if we don't get a solution, what we do is try again. And then if we still don't get a solution, what we do is try again harder. And then if we still don't get a solution, we try again really hard. We rarely pause and say, oh, maybe it's the model. Maybe I've got the wrong mental model to solve this problem. And then with a little bit of hubris that I kind of enjoy, he claims that there are 14, he's got 14 chapters in this book, 14 dominant flawed models out there that have superior alternatives, which he of course introduces in each chapter. So that each chapter is, here's the 14 chapters. There's we walk around, business people walk around with mental models of how to compete and who your stakeholders should be and all that kind of stuff. And in each case, he says the dominant mental model is flawed. And here's the alternative one that's obviously superior. So what we're going to talk about now, I think could easily have been chapter 15 of his book. We're going to talk about a very well shared, flawed mental model about how to implement information systems and what you could do instead. So that's what the talk is. I'm going to say all kinds of outrageous things. So maybe you want to know where these opinions come from. They don't come from boardrooms. They come from somewhere else. I started my career with Arthur Andersen, which eventually became Accenture. But back in the good days, it was a little bit different. Built a whole bunch of systems, many of them from scratch, because you did that back in the day. That Georgia Pacific, that's a big forest products company in the US. I'm pretty sure I designed their second ever payroll system, because the one we were replacing was written in assembler language. And it's hard to imagine they'd have done that twice, but you never know, they might have. Just built Bougainville Coppers is in Papua New Guinea of all places, and spent several years there custom building an ERP system for them. Some of that is just to say, I know enough about implementing enterprise information systems that these aren't just naive observations. I have some scars. I started a small consulting company, did a few more kind of similar projects, but that's right about when it dawned on me there was something fundamentally wrong. I was noticing myself and my peers and everyone else would just redesign the same application over and over again, but it'd be different. 10 people, 10 inventory systems. And all of a sudden you got 10 sets of terms and even implemented at different levels of abstraction. And I just started asking myself, why do we do that? Shouldn't there be something kind of bringing things back together, something that would cause us not to keep doing that, which is about when we, early 90s, started discovering semantics. There wasn't a lot written on it then, and there wasn't an internet, so you couldn't find what little there was. We got sucked into a .com, and we'd taken this idea of semantic design and said, what if you did a semantic design of applications? Not up to that point, we were saying, what's a semantic design of the domain of the application, but not semantically designing inventory, but semantically designing applications themselves. And it turned out you can build a model of an app. And if you have an engine that runs them, understands the model, if you change the model, the app changes. It was a really cool idea. We had patents, we had architecture, we had customers, we were at .com, we were deeply in debt. We absolutely had to go public in the winter of '99, got dragged out into the spring of 2000. And, the .com blew up, investment bankers vanished. We couldn't get at our intellectual property. So we decided to start a consulting company. And we thought this semantics thing was kind of a cool idea. So we called it Semantic Arts. God, what a great coincidence. The very next year, Tim Berners-Lee comes out with the semantic web. And we're thinking, God, last time he came out with the World Wide Web, everybody got rich. We got this made. We're just going to paddle out and wait for the big wave. And we paddled out and nothing happened. I wrote a book, nothing happened. Put together a conference and ran it for almost 10 years. Not much happened. We met the few people that were in the space at the time. And all the time we were, helping people with semantics if they would allow us to. And finally, people started asking for ontologies and designs, and we would design these things. And then we noticed they weren't doing anything with them, which was frustrating. We were creating shelfware and we didn't want to do that. So right around somewhere in the middle of that time period, we just started helping people, hold their hands and actually get these knowledge graphs and triple stores implemented. And it was some of that experience that led to these books. This one, Software Wasteland, kind of explains in excruciating detail how badly people can screw up information systems. And then a little bit of hope, what should you do instead? That's what we're going to talk about today. These conclusions. I guess this is what we do. We'll talk about a little bit way toward the end about GIST, but that's us. Here's, these are kind of our major clients. This is where we might have done some we might have done some experiments, but these are all non-animal subjects. So we've experimented on them, but they don't bleed. And then other companies that are either small and you haven't heard of them, or if they're large and you've heard of them, we did a very small project for them. Okay, so the question that Roger Martin would have put forward, or does put forward in his book, is if there is a predominant but flawed mental model, what's the evidence that it doesn't work? And here we're going to look at the existing application-centric approach through these 6 lenses, and then we're going to try something else. So this idea of legacy information systems. I found a family of squirrels living inside our legacy system. They're making demands. Whoops, I don't know where the demand thing went. Leave the acorns and nobody gets hurt. I think this is one of the systems I worked on. I mean, everybody laments the fact that they have all these legacy systems and they're sort of afraid to touch them. They're all convinced, they all have millions of lines of code, by the way, and they're all convinced there's business logic in there. And there is about this much business logic. One of those ERP systems we built, we did mostly code generation. So by the time we were done, there was, as systems were at the time, 600 screens, 600 reports, 3 million lines of code, but 99.9% of it was generated. There was only like about 20,000 lines handwritten. But had we not generated it, you wouldn't know, because it's all marbled through all the 3 million lines of code and nobody can ever find it. And they mistake simple validation for business logic, things like that. So it kind of fakes you out there. So everybody's got these things and they're a product of the predominant way we do things. In fact, it was Martin Fowler from ThoughtWorks who in the 1990s said the legacy systems of tomorrow are being written today. You go, yeah, God, a system from the 90s, yeah. And of course, in the 90s, everybody thought they were on top of it. Take for instance a classic legacy system that everyone has, a payroll system. And if your company's been around long enough, the first payroll system you implemented in the 60s or early 70s, and it costs somewhere around $1 million. And then you've now grown. The company is now twice the size it was, or whatever it is. And payroll has gotten 5% more complex than it was in the 60s. I mean, everybody thinks everything is way more complex, but all the way along, I've been implementing payroll systems, and we've added a few. We had a direct deposit. Whoa, we didn't have that back in the 60s. So it's a little bit more complicated. But if you want to replace your payroll system now, that's not $1 million. That's like $100 million. And you ask yourself, why? All these modern languages, does that make it 100 times harder? No, it's because when they put it in the first place, it was essentially a greenfield implementation. There was just, the payroll system was sitting there, nothing was attached to it, pretty easy. Now, everything is all, dependencies and APIs and data feeds and all this kind of stuff. I sort of liken it to a heart transplant. There's the payroll system and it's all wired into the rest of the firm, and rip the heart out, put a new one in, wire it back up. That's what a payroll system is. And it turns out, the heart transplant is actually kind of easy. Anybody can take somebody's heart out and put another one in. The tricky bit is wiring up all those veins and arteries, and nerves, and keeping the person alive while you're doing it. Anyway, that's what the legacy of this mindset for many decades has given us systems that are now effectively 100 times more expensive than they used to be for 5% more functionality. This is another legacy that we have of this way of thinking. We're now spending most of our IT budget just on integration, and frankly, not doing a very good job of it. You know, the amount of integration we have is pretty pathetic. And it's sucking up all the oxygen. And of course, you know, silo after silo after silo. Oh, even data governance is kind of a side effect of what we've been doing. You know, everybody thinks data governance is a good thing. We have to have data governance. But think about it for a minute. The reason you need an army of data stewards is because you have thousands of applications, each of which is so complex that, you know, you're lucky if you can understand 4 or 5 of these systems. So therefore you need a platoon and squads and all this kind of stuff of data governance. You know, what we're going to suggest in the future, if you get things simple enough, well, that's about all you need for your whole enterprise, not for, this is just emblematic of a gigantic tree that most companies have. And then this is the other place I was thinking about, sacrificing an animal would be pretty appropriate. But, and the last thing is, you know, this has given rise to this whole high priest mentality. You know, if I can just make my system complex enough, I become the high priest and you know, job security and all that kind of stuff. So that's what decades of application centric have given. Oh yeah, even more severe thing. We've gotten to the point where we think certain things that are so absurd, we now think they're kind of normal. So I was sitting around my office one day and one of my interns comes in and says, "Hey, I just heard about this system that has 500 million lines of code." And he's going, what could possibly be that complicated? I'm going, yeah, I don't know. What is it? He says, this thing called Healthcare.gov. And it was literally the week they were debuting it. I said, grab a pad of paper. And we sit down. He's got the pad of paper. We're going screen to screen slowly. There's a horrible system. And you know, we'd fill in our address and say, okay, how much code to do address validation? He's it's a couple hundred lines of code. They're not validating the address anyway. Take that away. And you get to the end, you go, wait a minute, what? That's it? You're just going to enroll me in a health plan? And that was 500 million lines, and at that point, $500 million. Turns out, by a funny coincidence, the next week I was at a conference and there was the CEO of this small company called Top Coder. And what they do, they got this whole bunch of developers on standby. And if you have a gnarly problem, you put up a little mini X Prize. You know, you can put up 25,000 or 50,000. That's typically what they do. And they have 2 or 3 teams compete for that prize money. It was mostly, you know, just to beat each other and stuff. So I told this CEO, I said, you're not going to believe this, but Healthcare.gov is a top coder size project. And we should go, you know, put a couple of teams together. So we were just starting to look for some sponsors. We need somebody with the 25 or 50 grand. When about a week later, I stumbled across this outfit called Health Sherpa, who'd already done it. Somebody just whipped up this thing, which was way better. Faster performance, better UI. In fact, Healthcare.gov eventually ripped this off, you know, reverse engineered it and called it Healthcare.gov Lite. I mean, how dismissive. It's better than what they had. But and so I ended up interviewing this guy because I didn't want to speak out of place. But this was the whole team later. The original team was about half that, you know, 6 weeks. They did what, by this point, by the time Healthcare.gov actually worked, it was $2 billion. And the reason I even bring this up is most everybody in Washington, D.C. and places like that just shrug their shoulders and say, oh yeah, you know, these computer systems are expensive. God, no, they are. Talk to these guys. Anyway, that's what decades of application centric have given us. Let's look at what the alternative is. What this is kind of a sneak preview of where we want to get people to. This is not the roadmap. We're going to have a little bit more of the roadmap in a few minutes. But right now on this continuum, if you're completely ignorant of data-centric, if you want to just keep doing another application-centric project, you're going to keep incurring tens of millions every major project you do. Because everyone's just like the last one. It's another 10 million, it's another open heart surgery. And then, but the idea is eventually, and it takes time, but that same project, just like Health Sherpa, should be hundreds of thousands. And small projects should go, right now, if you're in a large enterprise, even a minor project is hundreds of thousands of dollars, just all the stuff that you have to touch and things you're going to break. And we want to get that, to the size of a JIRA ticket. That's the essential idea. That's the goal. That's not really the idea yet. But when I suggest this to people, they say, oh, just take me there immediately. No, you can't take you there immediately. You have 1,000 applications. They're all snarled together. This is a journey to get from here to there. Let's talk about what that journey looks like. And if you're going to go on a journey, it kind of helps to know what the destination, where your destination is, or you'll get lost along the way. So the fundamental idea, and this is kind of obvious to you folks, but you'd be surprised, it's not at all obvious to a lot of people in industry. Start with your data model. Don't start with the business process or the business problem or the metric or the app or any of those other things. The data is the thing, and it's runaway complexity on the data is where all the cost goes. and this is the harder one, make the scope be your enterprise. In fact, an even better scope is your industry, but the enterprise is a pretty big scope anyway, not because you get sucked into saying, well, I'm just going to replace this one app and reducing your scope and only doing that. And then you end up with all the same connectors you ever had. No. So we've heard this story before. I'm just going to say one or two words about why it didn't work out and why this is different. ERP, enterprise resource planning. Oh God, I can't even believe I haven't unpacked that acronym for so long. I forgot what it was. But these big systems like SAP and Oracle intended to say, if we just had one model and put all the data for the company in it, we wouldn't have to do any integration because everything would be in the one model. And the problem is currently SAP, their one model has 90,000 tables, over 1 million attributes. It's hideously complex just by itself, but almost nobody has gotten more than about 20 or 30% of their functionality into it. And because of that, you then incur all the high integration costs of trying to integrate to a beast like that for only 20% of the benefit. So that didn't get there, and it's not going to get there. I was giving a presentation once, and somebody said, gee, isn't a data warehouse data-centric? Yeah, in a way, it kind of is. People brought all their data into one place and kind of conformed it to one model. The two or three difficulties. One was in the early days, there was some great intent to have the data warehouse be simple and conformed. It's in every enterprise we've been in, it's totally out of control now. One hospital client we went to did some analysis and found they had patient data in 3,000 tables in their data warehouse. We said, well, if you have patient data in 3,000 tables, then they were kind of proud of it, how much data they had about patients. We said, if you have patient data in 3,000 tables, you're never, ever going to know what's happening to your patients because you're not going to write a 3,000 table join, and no system is ever going to, do a 3,000 table join. But the real problem with the data warehouse is it's this dead end street that you can't get out of because you can't originate transactions in the data warehouse. So they continue to be reliant on the being fed by the legacy system. And so it's just sort of keeping that whole ecosystem in place. Service-oriented architecture actually had a bit of hope, back in the early 2000s. And where I think it went wrong was people didn't take a data-centric approach to it. They just said, we have this architecture, put all your APIs on the bus, and that didn't really change much. The few companies who'd said, only put your stuff on the bus if it conforms to a simple model, actually got somewhere. And finally, there was a fad for a while to try and have an enterprise data model. Some people now call it data fabric. It's sort of the idea of just taking all your complexity and lifting it up and trying to stitch it together. But the complexity is such that it really almost never gets there. So what's different about data-centric? One thing that's different is it works. That's always a nice distinction. And the other thing is it has these pretty specific characteristics. This is what we look for. In fact, the other day we were talking about something and somebody, or no, I guess it was yesterday. We were talking about fake fair, or how do you, the real symptom, I guess, of this whole fake fair thing is somebody once said the biggest obstacle to learning something is thinking that you already know it. And we had this one client that put together this data-centric council and all, they were big enough. They had like 20 CIOs, 20 different divisions. In fact, they had acquired Georgia Pacific. And every month they'd get together and talk about data-centric without actually knowing what it was. It was kind of weird. But anyway, this is a long word sandwich with a lot of adjectives in it, but I think it captures it. And I'm gonna decompose it one word at a time here in a minute. But just to say, the first little bit is, in a traditional system, application functionality is pretty tightly bound to the schema. You don't see it initially, but people sit there and code to terms that they see in their domain model, which are in the schema. And therefore, a lot of the code is very tightly dependent on their data model. So the first thing is just, do whatever you can. Some of it's model-driven development. Do whatever you can to be loosely bound to your domain model. But the model you're loosely bound to should be single, simple, extensible, federate-able, universal, shared, and directly implementable. What does that mean? In a typical enterprise, there isn't a single data model. There's one data model per application. If you have thousands of applications, which many people do, then you have thousands of data models. We are literally talking about having one core model at the center of your enterprise that covers most of the information you're going to find in most of your enterprise. Obviously, we're going to have some more detail elsewhere, but this is the core idea. Simple is one of the other distinguishing things. Most individual applications already have thousands of concepts in them, and the sum total of all your applications typically has millions or hundreds of millions. We're looking at something with in the order of 500 to 1,000 concepts. If you call a class or a property a concept, that's what we're talking about. Extensibility is this, and you guys know this, most of my audience doesn't. In a traditional system, there's no mechanism for extensibility. If you build an inventory system and somebody wants a few slight tweaks, they have to convince everyone else, to change the whole system for everyone. There just isn't a mechanism. Over here, the idea is you have a core ontology. Let's say you have implemented inventory control once. Somebody in some division says, oh, we have hand tools. So you have to keep track of who did you check it out to. Literally in a typical enterprise, the answer to that is go build, buy, or rent a hand tool system and then re-implement all the functionality that is easily shared, issue receipts, costing, cycle counting, adjustments, all that stuff. Nope, do that all over again. And then the next division over says, oh, we're selling produce now. So I want a best if used by date. I mean, you literally want to be able to just add one attribute and not build a whole nother system. But the knee-jerk reaction right now is always go build another system. Federate-able says, you know, in a traditional architecture, the way you combine information is by moving it and co-locating it. I mean, that was data warehouse. It's now data lake. People think as long as it's out there, I can't access it. But the reason they can't, well, partly there's no good relational mechanism to query something in more than one database. That's part of the problem. But the other problem is the schemas are all different. It's quite complex. It would just be logistically too hard. But these databases and these tools are made for federation. As long as you know what the map is, you can run a query across multiple repositories, even across graphs to relational or JSON or anything like that. By universal, we're talking about, this has been the holy grail in enterprises for decades now. How could I combine structured and unstructured data? And they have struggled mightily with this. You guys know better than anybody. We just use triples to say I can turn tables into triples. I can turn semi-structured stuff into triples. I can turn knowledge graph or social graphs into triples. I can turn text into triples. And the only trick is, can I conform it to my ontology? If you can turn it into triples and conform it, then problem is solved. This idea of sharing is also kind of weird. One of our clients, one of the first projects, very simple, just take all your employees and turn them into triples and put them in a triple store to solve the immediate problem. The next project we go to do also needed some employee data, but their knee-jerk reaction is, okay, now give me a copy of that and I will transform it. No, stop thinking that way. It's consumable as is. Don't copy it, don't transform it, don't change it. It's got URIs, it's fine. And it takes a while to get people over that idea that every time you want to share something, nobody shares anything. They just copy it and transform it. So, getting them over that little mental hurdle. And then finally, this idea of being directly implementable. We kind of lived in this world where there's a conceptual model of your data, and you turn that into a logical model, and you turn that into a physical model, and you implement that. And then supposedly, if you change the model, you're supposed to go back to the top, and nobody does that. They just keep changing the physical model. And even when we first started doing ontology work, we were convinced ourselves that we were building a conceptual model. We've even built the tooling, to turn it into a logical model and a physical model, until one day we just woke up and went, wait a minute, why are we doing that? It's person there, it's person there, it's person there. There is no useful transformation going on. There really is just one model there. When you get used to that, it kind of changes the way you think about things. So how would you know if you got there? And it is a journey. It takes a while, quite a while. One of our clients, when we talked about this idea that 500 to 1,000 concepts, said, that's something a motivated analyst should be able to understand over a weekend. We said, yeah, that's the whole point. And yet, in the current environment, nobody will ever understand your entire datascape. Any division can share most of the functionality of the firm and create their own distinctions. What it looks like in the end, I think, I haven't seen this yet, but every app will be completely independent from every other app. There'll be it'll be just a use case that knows the data model, but doesn't know the other apps. And just like on your iPhone, if you want to get rid of one app and put in another one, you don't do a systems integration project. It's because there isn't a lot to integrate there. And you acquire a new company, you got a much simpler model to bring them into. So, how do we get there? I'm going to go through this kind of quickly. What I was kind of fascinated thinking about yesterday when I was listening to you guys, almost every place that we go is a brown field. There's lots and lots of systems already there. There's some things here where you guys have a green field. There's whole, genomics, proteomics, metabiomics, and my son worked on the human vaginome project, and there can't be that much of a brown. It's just the data is not even 5 years old now. So in some cases, you got some sort of nice starting points, but here's generally the approach we recommend. Do just enough what we call think big of the enterprise ontology to be able to say, as I do individual projects, they're going to fit in rather than start over. Because the problem is most everybody wants to do things agilely and incrementally, but when they do that, there's the risk that you just create another semantic stovepipe. It's kind of easy to do. In fact, some of our guys were at the Knowledge Graph conference a couple of weeks ago, and the prevailing wisdom is that all ontologies are use case driven. Our guys are going, no, don't do that. That's doing this too much and not enough of that. You want enough at the top level design that this thing will grow properly. Here's just an idea. We typically do these sort of in parallel, a little bit staggered. We're building an ontology and then populating a knowledge graph. It's not a tiny proof of concept, but it's not a gigantic project either. These are what you're trying to do is get to where sponsors would understand what you're doing. Because actually, the problem is most sponsors are often not incredibly abstract thinkers. And when you talk about all the stuff we're talking about here, don't quite get it until you populate a database, solve a problem they're not currently solving. Then all of a sudden they go, oh, I get that. I think the key enabler here, and the thing we try and keep coming back to, is simplicity. It takes a lot of work to make something simple, but when you do, there's this gigantic payoff. Or to even simplify what Steve Jobs had to say here, the more simplicity, the more effective. So the two other things I want to say to wrap up here. One, you do need to find a sponsor, and a sponsor is somebody who can provide cover and create not a project, but a program. A program is a series of projects that, in fact, I like this sailboat analogy. A lot of people want to have a roadmap before they get started, but it is kind of like sailing. You may decide that we're going to tack this way for a while, and then maybe we do a pilot in a sandbox, and then maybe we productionalize that. Maybe we want to go back to the sandbox and make it bigger. Maybe, and you don't know ahead of time whether you're going to add architecture, whether you're going to add footprint, but somewhere you're tacking, trying to get somewhere, and what your executive sponsors is helping you coordinate a series of projects that are going to get you from where you are to where you want to be. So to kind of wrap that up, I do think it's time for a new model. The application-centric quagmire is just not cutting it anymore. The new model is data-centric, single, simple, extensible, federate-able, understandable, and shared model. I took out some of these slides in the middle but you guys already know these things: graph databases, semantic. I usually spend a fair bit of time on that third bullet. And then, think about both your sponsor and the journey being a lot of tacking projects. And then, if you want to pursue this further, our website, we have an upper ontology we call GIST. It's free. It's freely available. We've used it in probably close to 100 projects now. It's not life sciences specific, but nor is it contrary. I mean, there's a lot of things in there that you would use anyway. Just add water and genes and proteins. We have a conference coming up in a couple of weeks, and if anybody could make it, this is about 4 years ago, we realized that as you transition from application to data-centric, a lot of things that we used to hard code in application logic has to come out of the applications and go into the architecture. So there are things like authorization and entity resolution and validation and, just things like that, there has to be an architectural solution to replace that. So this is the 4th year in a row. We get a bunch of practitioners together. It's not a sales kind of a thing. It's just a bunch of people who each have pieces of that solution. So if you want to check that out, go to our website. There's 10 parts of the problem we're going to deal with in a couple of weeks. And then we have a manifesto for those who, believe. So that's it. I think we're supposed to take questions now.
Yes, indeed. Thank you very much.
Yeah.
That's fantastic. Thank you. So I noticed helps to switch the mic on. Anyway, I noticed that we've got some questions in Slido, and Ben, I think you've put one in, and Jared as well. So maybe you'd like to ask them.
Dave, I'll jump in first.
Yeah.
How do we overcome the ownership/high priest problem? It's the one I'm dealing with at the moment. I've got a data product called clinical data, apparently, and there are 3 groups that are building it, and they're all having a hissy fit over who owns it. So it's not
So
an IT problem.
This
is a business stakeholder problem, right?
Yeah,
but it reproduces this application-centric thinking.
And in this case, I was thinking of the high priest of the legacy system. This is you got high priest coming in on a new system.
The data mesh is driving data
Oh,
product.
yeah,
So
okay.
now we have, I own the data product. Everyone must come to me for that data.
Wow. That's a good one. I don't think I've hit that one yet. I don't know. Does anybody else have a thought on it? We hit it all the time on the legacy side, and the solution there is to kind of try and starve them out. Take the data out and just hollow the thing out behind them. But if they're doing it ahead of you, I don't know. That's a different problem. Does anybody come across anything like that? That's good. It's kind of a
Big stick.
yeah, kind of. Yeah.
At
Yeah.
some point, like bad behavior needs to be beaten down,
But I think this is, the data centricity doesn't just apply to IT. It has to apply to business thinking as well. We need the business to change the way they think about building, because ownership and promotion got attached to budget, right?
Yeah. Yes. Right.
Yeah, I think it only works if that centricity mindset is in the business side, right?
Yeah.
The technology side, they get it, generally speaking, and they can drive the execution of it. But if there isn't a desire from the business to do that, they're going to go their own way, right? These are R&D groups that have their own budgets. They don't need the IT budget to do this stuff generally. So the stick and carrot here may need to be a bigger stick. It may need to be an executive saying, ultimately, this is what you will do, and your performance is going to be assessed against your compliance with this to make it happen. And people just need to understand that there is a strategic value to the company in doing that. It's not just because the IT people want it. And this is that whole convergence mindset, right? We've been doing things the same way in pharma for long enough. Product data goes up, knowledge increases, but productivity doesn't. Why?
Right. Drop the mic.
So as far as sort of you started having the problem of having a data quagmire, once you start having a large enterprise shared ontology, how do you prevent that becoming a quagmire of a different shape when everyone's like, no, my address field has to be different. And then later on, application 3 wants to integrate those two. Do you have a gatekeeper over the ontology? Do you have a team that's responsible?
Yeah, and I think the key, I don't know if everybody heard it, is it possible to create a quagmire at the ontology level? And it is possible, but it's also mostly avoidable. What our clients, and one of the ones that's done it the best is an investment bank. And once they got kind of critical mass at the core, they set up this thing they called the consortium, which is, you know, anybody who has what they call skin in the game, wants to actually use this and reuse the actual data, things like that, come together quarterly, and then they have these side meetings in between the quarters to talk about either promoting new ideas into the core, or, you know, what is sort of allowed extensions, if you will. They're trying to create norms and behavior and things like that. So at least so far, they've done a pretty good job of not excessively extending that. And I'll tell you, even a little bit of sloppiness there is so much better than the status quo. We had another client who sells data for a living. They're a credit agency, and for them, a product is either an API or a data set. They have thousands of these products, each of which has hundreds or thousands of elements or attributes in them, and they're having trouble getting people to move from one to another. They decided to do an inventory. What's the total number of elements and attributes in all of our products? And they discovered they had 160,000 elements for sale in one way or another. And as we went through and started analyzing it, it's funny you use this for your example, they had 90,000 of those 160,000 were address related. It was mind-boggling. And you know, I like to think, well, in the solution we had, there's just a handful, of course, address attributes, and maybe if they doubled them, they'd be up to 20, but they'd never get to 90,000. But you know, this quagmire stuff, you get to 90,000 before you know it. Is there time for another one, or what time am I supposed to wrap? 9:30 or 9:40?
Yeah, 9:30.
Yep.
I think we can do one more.
Hi. So if you would encounter a company that has already tried to implement a system like that, but failed,
Yeah.
how would you encourage them to try again?
Yeah.
If they already spend so much time and money on it in the end, and they haven't really got anything out of it.
Yep. They call it poisoning the well. And it happens. I think the best thing to do is sneak off in some other corner of the company. You know, while it sounds like this is a centrally driven, you know, because I say start with the core and all that kind of stuff, actually, you just start somewhere. Like in the investment bank, we started in the legal department, but you still take the enterprise view. We're going to come up from the legal department, build it properly, and then build it out. So if they poisoned the well over here in, you know, payroll or something, I don't know, that payroll wouldn't be the place you'd poison. They usually trying to think, well, publishing. I was just thinking of electronic games client we have. They kind of poisoned the well over there in the publishing side. So you can't start there. Those people have too much recent memory. You have to go somewhere else and say, how would we start over here?
That's wonderful. Thank you very much. And I think there's a general comment on the Slido there about whether or not we should restart the SEM Tech conference.
Well, somebody else has, yeah, maybe we should. Somebody else has the Knowledge Graph conference going now. So in some ways, I think that's filling in. Yeah.
Cool. Lovely. Wonderful. Well, thank you very much, Dave, and also for keeping us to time and for such a really wonderful keynote presentation. Thank you.